Hello guys, welcome back to Talks Writers. In this video, we want to talk a bit about the process of compiling programs that are based on CGAL computational geometry library. So let's go for that. Okay, so CGAL. CGAL is indeed, a very huge library that is, I think we don't need to specify library because it's quite famous library. Yeah, the computational geometry algorithm library. And it's indeed, a library that includes lots of sub-libraries, I can say, or sub-modules. Here it's called packages for various operations related to computational geometry. And as you can see, it has, for example, algebra or different kernels, shape reconstruction, this kind of stuff. But the interesting part of this library for us is this mesh generation. And in the future, we will have, some video series for, taking advantage of CGAL for mesh generation and mesh manipulation in 2D and 3D. As you can see, even the mesh generation module had some sub-packages for 2D conforming mesh generation, 3D surface mesh generation, or 3D volumetric mesh generations, this kind of stuff. But in this video, I want to show you something related to this 3D mesh generation. But before that, we want to see how we can install this CGAL library. There is one funny fact here that indeed you don't need to install CGAL because CGAL is something they say header only library, which means that no compilation is necessary for it to be installed on your system. You just download the source codes and they're always in header files, .h or HPP, these kind of files in C and C++. And when you compile your program that takes advantage of various CGAL, let's say, features, you have to compile that specific part of CGAL as well during the compilation process of your program. This has some advantages and some disadvantages, but in general, it makes the process of development and especially compilation and deployment bit easier. And you will see that in this episode, and you can compare it with previous videos for compiling various other, let's say, libraries like GSL and MMG. So let's go for that, and then we will have a demo for this 3D mesh generation. In order to get started with CGAL, there is a quite nice introduction here. But the problem is this is indeed a very general requirement that CGAL, you have to download it. Like here, you have to download the source tarball. You can download it from GitHub as well. You have to extract it, and then while you want to build your program, you have to call a set of commands, and then that's it. But the problem is this CGAL has dependency on some libraries, but it depends. The number of dependencies depends on the specific package that you use. So this is indeed a very general, let's say, documentation, but depending on which of the packages you want to use, you may need to have other dependencies. But generally speaking, CGAL depends on Boost, GMP, and MPFR libraries. So these are the things that are indeed necessary for us. And then when we develop our program, you can see that we can also install it using package managers. I don't recommend it at all. When you want to configure your program, you have to provide it with a path to the CGAL library or headers in this way. You can see. And Also, then yeah, it may ask for some dependency problem and then make your program. So let's do that. Let's see that in action. So in order to use it, let's download, for example, this version, which is, as you can see in the URL, it is just a simple, let's say, download from GitHub. Of course, this is examples, but let's say for the latest version, let's go to the download page, and here on the Linux, we go to the releases page of GitHub, or we can directly clone the GitHub, let's say, repository. So this is indeed the beta 1 version. We don't want to go for a release candidate or something. So we go for one of these stable versions. And here we download this tarball version. There are lots of examples. The documentation is available also offline, and so on and so on. So let's download this one. And then, like other videos, we create a new directory here called CGAL. We go inside that, and we copy the file that we have downloaded, called oh, the download is not finished yet, but it is CGAL with capital C here. So we have to call tar on this, and then this one is we don't need to specify the Z here because this is not GZ. This is not in GZ file format, so we can say that extract and VF and then the name of the file. Let's see, you see that the examples, everything is included in this one. This is the most complete package. And then let's see what we have here. So we have the CGAL directory, and yeah, the source code, everything is here. We have the include, this is very important, and yeah, and the rest of the things. I don't want to go to the details. This is indeed just a video to demonstrate how we can compile programs using this and not the structure of CGAL. So let's create a test directory similar to the previous ones that we had in previous videos. And I have already a file called heart. Let me show you, before going for that, let me show you how let's go for the packages again, that generally how the source codes look like. So I go to the user manual, and you see that, this is, for example, a very general introduction to the 3D mesh generation. And yeah, this source, these are some concepts demonstration. Yeah, a very simple code would be something like this, that you call the header files, and then a couple of compiler directives to define various types, and then in the end we have the main function, and we call this we use this data structures to create a set of variables, instances of special classes, and then we call make mesh tree with the domain and the criteria for the mesh size and this kind of stuff, and then we'll write the output to a file, and the output will be like this. And as you go through this, you will see different examples for different use cases. But I have already created a file that is indeed you can easily find a similar stuff in the examples directory here, I mean. But this is something funny also, that this is indeed a mesh generation of a heart-like shape. And yeah, I already that you can find it in the description of this video, and you can create it for your own case. You can try to compile that. So this is in the name heart CPP. I copy it here. Let me go to that directory, which is indeed here. It was on the desktop, and I copied that to CGAL tests, and then this one. So let's have a look at this. As you can see, that this is very similar to that one, but a minor difference that it works on a some sort of implicit mesh domain. So we initialize an implicit mesh domain from this heart function, which returns a shape in 3D that resembles a heart. And then, yeah, very similar to that, we have the criteria, and we make the mesh based on that. To compile this, we need the headers of the CGAL library. And as I told you, this is a header-only library, and it means that we don't need to compile the program to compile CGAL beforehand. The specific part of that will get compiled during the compilation process. As yeah, it was here. I think I missed that. Yeah, here, when we want to compile that, the compilation process is built upon using CMake. So this is a sort of CMake workflow similar to the previous video. You know how to work with that, and you know that for CMake we need CMake Lists.txt, and with CGAL is released with a simple script that generates the CMake Lists file for you. And in order to use it, we have to call this script CGAL create CMake Lists in the script directory of CGAL. So the commands are here. The commands that we need to compile this are here. You can find, as I told you, in the list. In a link in the description, but yeah, this is not adapted to this let's say to this system on a virtual machine. So we have CGAL here and the CGAL uppercases and then scripts like this to be sure. I started from the beginning to be sure that it is the same directory structure. So this directory, and then this CGAL creates CMake Lists. And because I have only a single CPP file here, I don't need to specify the name. So I run it, and it says that maybe it's created. Yeah, you can see that the CMake List is created here, this file. And inside that, this is a simple CMake file that goes through various stages of compiling the program. And for this one to work, we need CGAL and Boost, as can be seen here. So Boost is required and CGAL is also required. So we have to specify, as is mentioned here. When we want to compile a program, we have to specify, the path to CGAL via this D switch that is specified the CMake variable, CMake compilation parameter, let's say. And for doing that, I cannot call CMake, but I need to specify a couple of parameters. And I also need Boost library. So the command is just like this. Let me copy it there and I show you how it works. So this one, you see that it goes to it says that it's CGAL directory. This is the CGAL. This space is completely optional. You can easily ignore that. So I don't have home CGAL, so I have CGAL. Okay, so for it to work, it should be like this. CGAL, no, the autocomplete doesn't work. Maybe like this. Yeah. So CGAL and then CGAL version 5.2, a recent version, and then CMake build type release. That's also okay, and it asks for the Boost directories, for the Boost path to Boost. So I have to provide it, and I don't need to the eigen library for this example, I think. Yeah, we will see. But apparently it was not in this. Sorry, it was not on the CMake lists file. It doesn't need the eigen library to be there. But okay, let's see. We will see during the compilation process. So now we have to obtain the Boost library. Boost is also, sort of accelerator, sort of, wide variety of different libraries under one umbrella, but for providing different functionality to extend C++ features. And we won't just download it. I think Boost is also a header only library, so you don't need to install it. You don't need to compile it. You can compile it to to get some binaries, but generally, yeah, Boost doesn't need compilation. So for this one, I download the latest version. It's a relatively huge file, and when it gets downloaded, let me open a new terminal, and I go to CGAL, and here I want to copy the download file called Boost version 1.76. So Boost file here, and then this one is GZ file, so I can extract it with gzvf and then a CGAL. Oh, sorry, Boost. And yeah, this one is a bit big, so it may take some time. Okay, so this is also done, and yeah, it's already over. And I need to also specify the path to Boost like this in the other command that I was executing. So here I say that path to Boost is let's say home, Tux Writers, CGAL, and Boost. And that's it. So now we have everything ready, I think. Let's see if those two libraries are also installed, MPFR and GMP. It notifies us about that without an error. So there are errors. Let's see what are the errors. It says, yeah, it complains about this GMP, lack of GMP library. So in order to install GMP, I'm not sure, maybe we can take advantage of this kind of package managers. I'm not sure if it is simple as GMP or maybe libgmp. We can search for that to see what is indeed the main let's install libgmp and see what happens. But we can also search for that. It's not a big deal. So in order to know, we can search install GMP Ubuntu, install the latest version of GMP. But this is for a very, very old version of the GMP, so the dev is enough. We can go for this one here, libgmp 10. This is the latest version, so that's okay to install this. What's that? Libgmp is already the newest version, but it was complaining about lack of GMP. I don't know. Oh, it should be dev, libgmp dev. Let's see which version of that. Yeah, lib version maybe 4. I don't expect that to be like this. No, this is still 10. And it also suggests that this should be installed, MPFR, so we can install that one as well. Cool. So now we have those libraries installed. And let's go back to our CMake command. And now this is indeed finished. We can see that these kind of CMake files and CMake dependencies are all here. And here we can simply type make. And now you see that the part of CGAL and Boost library, the parts that are needed, are also getting compiled here. And yeah, the reason that it takes a bit long is exactly like that, and you can see that it is indeed compiling things inside CGAL. After it's finished, we can run the program, and the program will write a heart.mesh file for us. Let's see how it works. Okay, it's over, and then we have here this heart executable file, and we can run it. Heart. And it's done. And you saw that this is indeed the way that it works. It's okay, how to compile a CGAL-based program and how to run it. So we have here heart, and we can easily visualize that using GMSH. Or I could have passed that using the command line tool. And so you see that, yeah, we have here this geometry. This is indeed the mesh that is generated with about, yeah, about 4,000 of elements. And of course, sorry, for surface element, and this is indeed 15,000 of 3D elements, let's say. Okay, so this is indeed how it works, and you see that we have the final shape here, and yeah, this is indeed the output. So as you saw, it was pretty simple. What you needed to do was downloading the file, downloading the CGAL tarball, and the dependency. In this case, it was Boost, as well as 2 other libraries. We installed them using package managers, and in the end, we were able to compile or program. You can go for more complex programs, but in this way, using these techniques, you can easily build all the examples that you see in the examples directory of CGAL and try to investigate different features of that. So yeah, make sure to check it out, and yeah, see you later. Bye.